Hello, Einstein fans. Welcome to another Einstein Facebook Live on the Einstein Facebook page. We're so excited to be here live at the Scientific American magazine offices here in New York. We're going to be talking about the science of comic book superheroes and Einstein's connection to those superheroes. And I'm really excited about this conversation, and I'm excited about my guests more specifically. So, quick introduction. To my immediate left, I have Aaron Schutak, who's a copy editor here at the Scientific American offices, and we have Lee Billings, who's an editor for Space and Physics here at the magazine. To just kick the conversation off, just to lighten the mood a little bit, because we're on the subject of comic books, who's your favorite comic book superhero? And maybe if you want to explain why, just to start up the conversation.
I would say Popeye from the original E.C. Seeger comic strip Thimble Theater.
Okay, I'm sure that's not. Hardcore comic book fans would probably know who that is. Yeah. What about you?
You got a purist here. In that case, maybe I'll go with Little Nemo from the Windsor. What was his name? Windsor
McKay.
Windsor McKay strips. Beautiful, gorgeous stuff he did every week in like old newspapers back in the 1920s, I think. Or Miracle Man. Alan Moore's Miracle Man. Huge fan. Flawed superhero with crazy Superman powers. Just awesome.
I guess I'm just going to go old school. I'd probably say Iron Man.
There we go. Okay.
I love Iron Man. Actually, I love Batman. So there's a close tie there. But anyway, we're here at Scientific American magazine's offices. Just a front cover of an old issue of Einstein that has been featured on the magazine cover. And like I said, we're going to be talking about the history of comic book superheroes and Einstein's connections to them. In doing research and preparation for this, not many people know that there's a connection between Einstein's science and many of the superhero powers that a lot of these superheroes have. And I wanted to just tell a really quick anecdote before we kick off with the actual discussion of the subject. There's a comic book, and by the way, we have a whole array of Einstein comic books here, or rather comic book cameos of Einstein in various DC and Marvel comics, although we have one from Charlton Comics, E-Man, more
But we can't show them to you. We don't have clearance, but they're all here.
They're all here. They're all here. We promise.
Guaranteed.
So, we're going to be running a Gandankin experiment here,
yes.
so it's all going to be fine.
Just visualize.
But if you want to do your own independent Google search, DC Comics presents, I believe the issue is 69, but it was published in 1984. It's Superman versus Blackhawk. And in that issue, Clark Kent, I think, goes back in time to the 1940s, and he's abducted by the Nazis, and he's taken into some secret room, and lo and behold, who's also being held captive? Albert Einstein. And when Einstein is there, Clark Kent's existence as Superman at that time in the 1940s was non-existent, at least, that's what the comic says. So the Nazis then go into the room, and they tell Einstein, you're a genius, right? You have to make a formula that will make a human invincible. So then Einstein says, but I'm a physicist, I'm not a biologist. So the Nazis say, you will or you will die. So there's that threat.
So then quite possible that was accurate.
Yeah.
What the Nazis were actually trying to do.
Probably. So Einstein's mixing all these chemicals. He doesn't know what he's doing. He's been spending hours doing it. And then Clark Kent says, whatever Dr. Einstein's doing is not working. If I use my heat vision and pretend that he mixed a chemical and caused a reaction, maybe that'll create something. So sure enough, Clark Kent uses his heat vision, the glass cracks, and then all of a sudden, Clark Kent gets splattered with all this chemical, and Einstein's so apologetic, and then Clark Kent says, oh, I'm okay, but all of a sudden I feel stronger. So he lifts up a desk, and then he crashes through the wall. And, Einstein says, you have to tell the whole world that this was not a birthright, that science made you into this. And then Clark Kent says, I'm definitely going to tell the world. In fact, I'm going to fashion a suit with a big S on my chest in the name of science.
Science man.
Exactly.
That's what it really stands for.
So I wanted to tell that story really quickly because I think that sets the tone for this conversation. Just as a start-off, kickoff question before we get into the actual science of it, do you see in your own experiences people say, they'll pick up a comic book and they'll say, I love comic books, but I'm not a science fiction fan. Wouldn't you guys agree that that's in some way the ultimate irony, that in some way there is science embedded into this, but it's not marketed as science fiction?
Yeah, I think so. It seems like a lot of the ideas that we see, that scientific ideas that make their way into comics, do often come from science fiction, typically, pulp stories from the 1930s and 40s, science fiction books from the 50s and movies and things like that. So yeah, I think that is something that is real. There is a connection between science and comic books and really all forms of popular media. And I think the conduit, as we said here, was science fiction books mostly. Right. Stories.
Yeah, I would agree that a lot of the science that might appear in comics generally will have come there via science fiction. It's very much a hybrid form, though, when you're talking about superheroes, that so much influence came in from the pulp heroes like Doc Savage, from comic strips like The Phantom. Right. So just sort of all mixed together in this singular little hothouse that then kind of developed on its own. But
That's right, exactly. So with that said, we have a lot to get to. We're going to spend almost an hour talking about this. It may more or less, we'll wing it. But just so you guys are aware, if you want to chime in and share any questions, we'll take a Q&A at the end of our chat. We'll have some time to spare. But I think we're going to have a very light and hearty discussion about some of this stuff. So we're actually going to delve into this conversation talking about some of the scientific principles of Einstein and do some application to some of these superheroes. So I wanted to start first with special relativity. One thing that we've noticed across the board with Einstein is that he's well known for his thought experiments, and this is one of the first scientific theories where Einstein's thought experiments are really put into effect. And one of the experiments was Einstein imagining a beam of light racing through space, and you guys can correct me if I'm wrong about this, but he's racing alongside a beam of light, and he realizes that nothing can move faster. So it just makes me think about, I guess the twin paradox, if there's any connection to that necessarily, but when I think about, that type of racing and that early conception of speed, I think of The Flash. I think of time dilation. I think of one of the comic books that is commonly talked about, and it's really well known among the comic book fan base, is Superman and The Flash racing each other.
That's right.
So why don't we talk about that science more specifically, and even the applications to that with those superheroes?
Oh yeah, I mean, so excuse me. This is something that dates back to I think when Einstein was only 16 years old, and essentially, he was, as you said, imagining he was running alongside a beam of light, some versions riding along a beam of light. And the idea is that he realized that light, nothing can move faster than light. He's trying to imagine moving faster than light, kind of running up against Maxwell's equations, realizing that's not possible. Well, what happens if light, if nothing can move faster than light, that kind of means you can't freeze light. Light doesn't really feel time. Well, that means that time is relative. And that's kind of where we get this idea of time dilation and really also, light. Well, the speed limit of light being the ultimate speed limit, goes back to Maxwell's equations, things like that. But Einstein was the one who really tied it all together. And so here's a great example where we have this very clear image, very clear visualization that led to this insight. And then I think that also really leads to things like, has the Flash ever raced a beam of light? I feel like he must have, or at least he has, but he's probably exceeds it, of course, because then he can do things like vibrate all his molecules to go through a wall, or go faster than light to maybe go back in time, or
which we actually had a preview of that, and not in the comic books, but we sort of had a preview of that. If anybody saw Batman v Superman, spoiler alert, Bruce Wayne is in the Batcave, and all of a sudden, who's there? Barry Allen is telling Bruce, back in time, you have to stop it. You can't trust him. He was talking about Superman at the time. Maybe this was the Vision, if you will, or maybe there was some alternate universe that took place there. But was the speed enough that he was able to go back,
travel back in time?
Yeah,
that's interesting.
And the one thing is, we don't even know how many years back this is, because was this Barry Allen, talking to the current Bruce Wayne from 5 years ago, 10 years ago? We have no idea necessarily, but certainly that conversation or that idea, that scientific principle, could be
Yeah.
heavily considered in some way.
Well, interestingly enough, according to special relativity and this thing we've been talking about, the idea of time dilation that springs from the notion of the speed of light being absolute rather than time, is that it says you can travel into the future really easily. We're all traveling into the future right now, right, at a rate of 1 second per second.
Right.
If you're moving faster than light, I'm sorry, not faster than light. If you're moving closer and closer to the speed of light, time slows down for you. And then, obviously, for observers elsewhere, it's going to be going at a different rate. So you can imagine things like the twin paradox. Is it called the twin paradox? Or essentially, you have two twins. Let's say we're twins. You get in like a rocket ship. You're going at like nearly the speed of light, and I'm just chilling out here on Earth. And by the time you come back, maybe I'll be like, figuring out Social Security for my retirement, and you'll still be you, just barely aged. Which means that effectively, Aaron here could travel into the future, but special relativity doesn't say you can travel into the past.
Right.
So Barry Allen, in that case, is actually breaking laws of physics, kind of as we know them if you're thinking about special relativity.
Right.
Which is all simply to say that, if I were Barry Allen, if I were the Flash, I would probably spend a lot of time traveling near the speed of light just so I could maintain my youthful good looks. But that's just me.
Aaron, any thoughts to add to that? In terms of speed and the ability of time travel, if you will.
Sure. I mean, when you talk about the twin paradox, a lot of the idea is that when time is moving at different rates for different people, one person is going to age a lot more. And these kind of concepts have appeared directly in comics. I'm not sure if they've accurately been depicted in superhero comics specifically. They've been accurately depicted in at least a comic book adaptation of the novel The Forever War, in which an astronaut goes off to fight a war in space, and every time he comes back, time has passed, on Earth by months or
he's moving
centuries.
relativistically.
Yeah, exactly. In comic books that involve superheroes, I'm definitely aware of that occurring in terms of alternate dimensions where time moves at a different rate. Ilyana Rasputin was an X-Men character who is a little girl. She's kidnapped into limbo and comes back as a teenager who thus can be a superhero on the New Mutants.
Great nugget. Yeah.
What is her name, though? What is her superhero name?
Now I am trying to remember.
Put you on the spot. You're flexing the knowledge. I thought you had it ready. Oh, okay.
It wasn't sorceress, but it was something like that.
Okay.
But what's interesting about that discussion now is that you're talking about alternate dimensions, and we are getting into a conversation now. Einstein's special relativity really paves the way for us getting into general relativity, and that's where Einstein is well known. We've celebrated the 100th anniversary of Einstein's theory of relativity. This is where we get the understanding of mass and time, and how basically when you have the space-time fabric is shifted in some way based on what's existing there, and so much more. You get into a whole discussion of energy alone and whatnot. But I want to parse it out as much as we can for this discussion. So,
I could add that there is a sort of meta effect of time dilation with comics in general, that if you go back to the Golden Age through the Silver Age, time goes by very quickly in terms of the fact that stories will occur within the pages of a single comic book, within just a few pages in the back, whereas through what was starting to be referred to as story decompression in the 21st century, now it'll take many, many issues to tell the same story. So if you have a flashback in a current comic to, say, Spider-Man reliving his origin for the 50,000th time, then it's going to take a lot longer than it did in his initial appearance.
Right.
So it's the opposite of real life, where like the older you get, the faster things go. Okay.
That sounds right.
Yeah, so basically a Benjamin Button effect.
Oh, God.
You're mentioning, though, general relativity, which, as you said, is kind of the equivalence, or the idea of space-time, the idea that mass tells space how to curve, and then space tells mass how to move. And that seems to have also come in part from another thought experiment, Gedanken experiment that Einstein did, where he was imagining being in an elevator that's just closed off, you can't see anything outside, and then all of a sudden, you're pinned to the floor because the elevator's moving. Well, or is the elevator moving, or is it in fact that you're all of a sudden in a very powerful gravitational field? Is it being accelerated up, or are you being pulled down by gravity? And in the same way that he kind of saw this equivalence or relationship between the speed of light and time, in special relativity and general relativity, it's more about the equivalence that exists between acceleration and the force of gravity. And that's what led to the idea of space-time, which leads to things like our current understanding and description of black holes. These points of kind of, these singularities that happen, infinitely dense, infinitely massive, kind of causes no one really knows exactly what happens, but we know they're around there. Some people think, for instance, that a black hole could be a portal to somewhere else in the universe, or another universe.
Like what we're going to see in Doctor Strange in the movie, and what we've seen in the comics.
Yeah, wormholes, for instance. And wormholes actually trace directly back to a paper, I think in 1935, from Einstein and a fellow he was working with named Rosen. And they were trying to resolve this idea of a singularity, the idea of, it just seemed kind of abhorrent to them. You could have this thing that collapsed and made all the laws of physics seem to break down. All of our descriptions just ran away to infinity. Nothing made sense in the equations. And they're thinking, well, there's got to be a way to work around this. So I'm going to really mangle this really badly, embarrass myself. But it was something about how instead of collapsing centrally to a singular point, they were looking at maybe this concentration of mass or energy would kind of collapse radially. And that's how you get this extension, this kind of like throat of a wormhole that could lead to some other place. It's all very, very, very speculative, and lots of people have extended on that since the 1930s. People like Kip Thorne, who's helped with gravitational waves, was a key advisor for Interstellar, Christopher Nolan's Interstellar. But yeah, there's a lot of that's a big, rich playground there, and just if you think about a wormhole here, for folks at home who haven't done this, I've always wanted to do it. Is there a piece of paper I could use and a pen?
Yeah,
right.
Yeah.
Like, I'm going to just use your notes. The idea of wormhole again is that point A, point B. What's the fastest place? Okay, to get between them, it's a straight line. Well, actually, no, because space can bend, and then you get to do this. Right? That's a wormhole right there.
Yeah.
And now I've ruined it. But hopefully they're still legible.
Yeah,
so
that's so good.
Whenever a superhero like Doctor Strange opens up a portal, via the uncanny, via the dread eye of Dormammu or whatever it is, actually that could easily be explained in the laws of physics that we understand as the creation of a wormhole. Even though in the case like that, it would probably take, again, something like a black hole being there, which is such an immense concentration of mass and energy that if you opened that, you would immediately be vaporized into your fundamental particles and just evaporate.
So much like Anthony's paper, it would have a destructive effect.
Yes, it'd be a bad thing. I probably wouldn't want to go through a wormhole, guys. Just let you know.
Another thought experiment of Einstein's when he was conceiving the idea of general relativity is his happiest thought, where he talks about how he imagines a guy on a roof and he falls. And
that's so happy.
Lol. So he falls, but the question is, will he have any mass as he's falling? And if Einstein's thought experiment is such that if he were to put himself on a scale as he's falling, he's going to have no mass, which begs the question: is he flying? Or is there some type of other gravitational effect? And you automatically think of every superhero who has the ability to fly. You think of Nova, Captain Marvel. I guess in some way you could even think of somebody like a Batman or Spider-Man, where they use some type of projectile to help them move in some way and then fall down in free fall motion. So, is there any correlation to the happiest thought and that conception of flying?
I guess there must be. So it sounds like Einstein, was he like one of the original trolls? He's like, oh, you want to lose weight? Whoa! Is that kind of, no, of course not. No, not at all. Maybe a little bit, he's nodding. I guess there's, it seems, flight in, I've never really understood flight in comics. There's so many different ways to handle it. I just don't understand. We could go into the different varieties, right? But Superman just straight up doesn't make any sense, right? Is it like anti-gravity? Is there some kind of anti-gravity field going on?
He's a Krypton.
Right.
Krypton. What do you expect?
We're going to get into that, right? We're going to talk about, but
You're going to have to learn how to fly eventually, because in the beginning, I believe, he could just jump really high.
He could just jump like the Hulk,
It's more like
which
a
actually
fluid.
kind of makes sense, though, right?
Right.
Because it's like, force, mass, acceleration, right? It makes more sense instead of just anti-gravity. I mean, I guess you could do anti-gravity with, what? Well, okay, so let's say there's this thing called dark energy, right? The universe is expanding at an ever-expanding rate. It's accelerating in its expansion. We know the universe is expanding. We can see the galaxies at the far edge of the universe moving away from us faster and faster, right? Moving faster and faster based on how far away they are. The further away they are, the faster they move.
Mm-hmm.
People have looked at very distant supernovae and various other observables for the far distant universe, which is also the far younger universe, because we're seeing back in time. We look across vast things of space.
Yeah.
And they've noticed that these supernovae are a little fainter than they should be, which means that they're probably further away than we think they should be based on our naive projections of a smooth and constant rate of expansion, or rather just a kind of a linearly accelerating rate of expansion. So we're seeing, I'm mangling these terms again, but we're seeing an acceleration in the expansion of the universe, which is dark energy.
Mm-hmm.
We don't know what's causing it. One idea is linked back to Einstein. He had an idea called the cosmological constant, which he put into his equations when he was trying to think about kind of a theory of everything for the universe to describe how the universe evolves and behaves. Einstein was a big fan of what's called a steady state universe, one that doesn't necessarily get bigger or smaller, just kind of stays constant the whole time. The way he did that was the way he kept things from, for instance, collapsing all back in on themselves into their own weight or escaping freely out, expanding forever like we kind of see, is to have this balancing equation, this cosmological constant, which is like an anti-gravity kind of. So, since we know that dark energy is out there and it suffuses everything around us somehow, even though we don't know what it is, we could say that maybe the superheroes who are using this anti-gravity force, I don't know about Superman, maybe some others, are actually tapping into dark energy.
It could.
They're tapping into dark energy, guys. and dark energy is the most potent energy source that seems to exist in the
Actually,
universe.
wasn't it just named the fifth force of nature?
Well, there's always a fifth force. That's like
okay.
a science journalism thing where like every other week there's like a new fifth force that people propose to discover, and it gets pretty gnarly. But yeah, it makes up something like I think 73% of the energy density of the universe. If you think about all the mass, all the stuff in the universe, the matter and the energy, most of it is dark energy.
Right.
So we could say they're tapping into that, and that's how they fly.
Very interesting.
Now, Lee, are you familiar with Jack Kirby's illustrations?
Well, yes. Yes, as a matter of fact, I am a big fan of the curves.
So one of these stylistic points that Kirby tended to put into a lot of his illustration is referred to as the Kirby crackle.
The Kirby crackle?
Yeah. It's basically...
Was it spelled with a K?
Yes, it is in fact.
Oh, wow, nice. Good to know.
And it's basically looks like stippling that's really, really large. And he would tend to put this around things that were supposed to be really energetic or powerful.
Mm-hmm.
So, somebody might be holding their fist like this, and the fist will be glowing, and there'll be all these
Right.
like black dots sort of melding into blackness around that. So if we were going to just make stuff up off the top of our heads,
Sounds good to
we
me.
could claim that this was dark energy, and
Yes.
that all these Kirby characters were just
We're
tapping
just channeling
into it.
the most potent energy source in the universe, which was related, again, Einstein kind of came up with this as like a little notation, just a little crib to basically be like, oh, these equations don't explain. He talks just like that. And then, yeah, so it's one of these cases where, he called it his biggest blunder, supposedly, even though some physicists like Mario Livio will say he never actually wrote that or said that, but it's been called his biggest blunder. And yet, here we are, even his mistakes turn out right.
Yeah, in some way, yeah, exactly. So one other scientific theory that Einstein really helped, I guess, perfect, if you will, and it's been perfected and understood over time, is the notion of Brownian motion, which you guys can explain the science of it, but immediately, when you think of Brownian motion, just in its bare bones or broad picture, you think of atoms and the motion of atoms. And I'm just visualizing in my head, what if Ant-Man or the Atom, who had the superhero ability to shrink to the finest micro, like to the size of a micro, like organism, something so small that the naked eye couldn't see. Could they, theoretically, based on the science of these comic books, could they theoretically see Brownian motion in its full effect?
Well, in its full effect. So, okay, so Brownian motion goes back to a guy named, I think, Robert Brown, who in the 19th century noticed that pollen grains, little tiny, very, very light pollen grains suspended in water, would just kind of wobble or just kind of be like, whoa, what's going on in here, guys? And you couldn't figure out why they were moving so much. It didn't seem to make sense. And he called it Brownian motion. And there are a lot of theories, lots of work on it. Einstein was the only one. But what Einstein did was he actually developed a formula that essentially predicted and explained exactly how Brownian motion works, how it behaves, and it all came down to the existence of unseen atoms.
Right.
And actually, it became one of the cornerstone proofs that atoms really exist. Like, people had for a long time been saying, atoms, yeah, okay, sure, I guess they exist, maybe. And then Einstein's work with Brownian motion was one of the things that said, no, for sure they do. You really can't deny it because my equations exactly explain how this motion works and how it should behave, and can predict the way a pollen grain will move, and the only way it does that is through my understanding and modeling of atoms. So you can imagine like Ant-Man or the Atom, the character, shrinking down and maybe seeing like something being subjected to Brownian motion, or I guess you could shrink them down to the point where they are themselves the size of atoms, then kind of do an elbow drop or something on a pollen grain and have it go spinning off in water. But of course, the trouble then is that you're going to have a lot of trouble seeing anything because you're smaller than the wavelengths of light that are actually projecting, sending information. So then you'd have to be seeing in electrons or something, which is actually also related to something that Einstein did. And this is what he won the Nobel for, along with Brownian motion, was his work on the photoelectric effect. His earlier work, everyone knows about Einstein through special relativity and general relativity, his understanding of space and time and light. But really, more fundamentally, his earlier stuff was all about trying to understand the fundamental constituents of the universe, the fundamental pieces of matter and energy that we deal with. So, again, things like atoms or light, photons. Before Einstein was working on this problem, people already knew, for instance, Planck. Max Planck had this idea of a wave-particle duality. Sometimes a light acts like a wave, sometimes it acts like particles. The best way to really study that and prove it is something that Einstein studied called the photoelectric effect, which, let me see if I can reel this back in. I realize I'm just kind of rambling. So real quick, the idea that light is a wave comes from something like the double slit experiment. You can have two slits and let me use your paper again. But you imagine two slits in a piece of paper, you shine a light on it, and the projection pattern you would expect on the back would be just two little slits of light and then darkness. But you don't get that. You get this really weird interference pattern, and that's because the light is interfering with itself and choosing which one to go through. You can even do this when you send individual photons one at a time at the sheet, right? And you'll still get this pattern, which is just bizarre.
Right.
So that suggests light's a wave. The idea that light is instead a particle comes from the photoelectric effect, which is that let's shine a light on a piece of metal. Maybe even this would work.
Yeah.
And it will release electrons. The light will release electrons. Now you'd expect that the brighter the light, the more electrons you'd get. But that's not what we see. What we actually see is that you can have very, very dim light, but if it's at a very high energy, high frequency, then it will release more.
Is that based on the metal itself or the substance that it's bouncing off of?
Well, it's based on, it only works, I guess, with certain metals, but it's based on the idea that light is knocking electrons off of atoms in metal. And again, since you would expect that the brighter the light, you'd get more electrons. Instead, you can have dim light, but that is high frequency, high energy, and that gives you more electrons. That really strongly suggests that when an individual photon, even though there's not many of them, if there's one that's very energetic hits, that's what causes it, which leads to the idea that particles or that there's photons, that there's particles instead of waves. Gosh, that was really complicated.
That's a mouthful, but that was a good conversation.
I don't know if that makes any sense. Essentially, Einstein worked on that, proved the photoelectric effect and Brownian motion. And the photoelectric effect could also be, in terms of superheroes, maybe linked to things like Superman's powers.
Right, and just like a quick the story about that. And actually, if you're just tuning in with us, we're here at Scientific American Magazine's offices. We're talking about the science of comic book superheroes and Einstein's connections to those. There's Aaron creeping out, but we're talking about the science of these comic book superheroes and Einstein's connections to them. So the photoelectric effect is a great scientific theory that I think in some way kind of pairs with one notion in comic book lore with Superman. when Superman when Superman has left Krypton and has come to Earth, in an effort to charge himself, if you will, to harness this great amount of energy, he probably was immune to skin cancer, but he had to go all the way to the sun, the surface of the sun, and absorb all the energy in order for him to go and fight on Earth and fight crime and whatnot. So when I think of and actually the comic books have called that the photonucleic effect, not the photoelectric effect, but the photonucleic effect. And Aaron and I were talking about this, and scientifically there's not an exact pairing with the photoelectric effect. What it sounds like with photonucleic effect is more photosynthesis. Like if you have a plant and you water it and you put it in direct sunlight, the shine from the sun is going to help the plant get nutrition and whatnot. But it seems to have more of that correlation. But at the same time, when you think about it, I guess you can make some type of mystic argument that if Superman goes to the surface of the Earth, he gets the sunlight. Could he theoretically get some type of could some type of chemical or something
why not?
protrude from his being?
Yeah. So the way I like to explain this, I don't know if this is canon or not, but photosynthesis is obviously where you get light, and light is actually the energy source that you use to synthesize biological molecules and run a metabolism, right? Biochemistry.
Right.
So that's related to the photoelectric effect because we were talking about how light has the power to knock electrons off things, right? Well, in photosynthesis, light knocks electrons around in chlorophyll and stuff like that, and actually drives things like the splitting of water, the creation of free hydrogen protons, and that is linked into a huge, elaborate metabolic machinery that powers plants and then we eat them and powers us. So you can imagine, for instance, Superman growing up on Krypton, which is orbiting a really dim red dwarf star, which is the most common type of star in the universe, by the way, guys. So maybe Superman's really out there. I don't know. But these dim red dwarf stars, if the sun was like a 50-watt bulb, a dim, one of these red dwarf stars is going to be like a little Christmas light. Okay,
right.
So a lot dimmer. Life's harder there; it has to be pretty close up, and you can imagine maybe life evolving more efficient routes of photosynthesis there, right? Because there's kind of less light, not as much to work with. So it really is just on the margins. It's just trying to drive its metabolism with this little Christmas light instead of a 50-watt bulb. So now what happens if you transplant a life form from there, I can't show him, he's right here, like Superman, to a yellow star like our sun, and all of a sudden his metabolism that's used to this little tiny dinky thing is just like, well, what is this? Whoa, I'm supercharged. So you can imagine something like that, right?
Sure.
Now the trouble is that we also know, and this I'm cribbing or hedging a little bit, but we also know from special relativity that there's this equation called E equals mc squared.
Mm-hmm.
Energy equals mass times the speed of light squared. And what that really means is that every little bit of matter, every bit of mass, rest mass, has an immense amount of energy in it. But you can also use that and then tie it into things like general relativity's limits on how to make a black hole to have essentially energetic limits on how much energy you can have in one place at one time.
Right.
It certainly would the things that Superman does, for instance, what's the craziest thing he's ever done, in terms of energy expenditure? I don't know, but it's crazy stuff,
That is a
right?
big question.
He does
That's
crazy
a
stuff
in the
all the
Silver
time.
Age, actually.
Yeah. So,
I guess you could say his fight against Doomsday, which leads to his death in some way, had to
have been the most. So
Yeah.
you imagine those sorts of expenditures of energy, and they would totally supersede any sort of biological mechanism. So the photonucleic effect could not support enough energy to do the sorts of things he's doing. Second of all, he's probably at some points making enough energy, concentrating it in a small enough place to create black holes.
Right.
So at that point, it's like I'm punching you really hard, and everything's gone. We're in a black hole. This sucks, right? So there are you have to bend the truth a little bit when you're dealing with comics, but
Absolutely. So I want to definitely save some time. We got about 15 more minutes before we'll take Q&A. I want to touch on the whole notion of radiation because Einstein's theory of general relativity has given us this understanding, if you will, of nuclear activity and I guess the ability to understand how much energy can be harnessed. And we have seen that throughout time in comics where there are superheroes that are exposed to massive amounts of radiation. The Hulk, hence the T-shirt, which we'll tell you where to get the shirts at the end. We have Lee and Aaron modeling some Super Einstein T-shirts. But we have the Hulk, who's been exposed to radiation, if you will. if I'm not mistaken, you said that X-Men, that was some of the early incarnations, if you're not mistaken, were dealing with this notion of radiation and how that could affect genetic molecules or whatnot.
Yeah, Professor X's dad was a nuclear scientist, so he was exposed because he was on the job, and was warned that his child, could be affected.
Wow.
Which I believe was pretty quickly dropped as a concept in favor of a pseudoscientific take on evolution instead.
Sure, yeah.
I mean, radiation exposure can cause things to mutate and hence evolve. It's just most times those mutations end up with you being like a, nothing. You don't survive, right? So, but yeah, I mean, let's bring it all home. In terms of radiation and Einstein and a lot of these superheroes who do get some type of exposure to radiation. Well, I guess we could break it up into two parts. One, why are comic books so obsessed with this notion of over-radiating their primary characters? And B, is that science accurate, if you will, of, could, that massive amount of radiation or energy, could that, does that jive with the laws of physics? So we know that energy, or that radiation is a very potent energy source. Again, back to E equals MC squared. I mean, you can kind of just, it's related to that, where if you can even look at something like how much plutonium or uranium is actually fused or rather split in a nuclear bomb, and it's usually a very, very, very small amount. And the reason why it's a very small amount and we still get this huge blast is because of E equals MC squared. So that's kind of just indicative of how much energy, why there's a lot of energy to be had from a lot of radioactive or nuclear power. In terms of why why comic books are so interested in over-irradiating their characters, I guess it's just a post-war thing, essentially, where, we had nuclear power, we had nuclear weapons, they were really cool and shiny, and it made America the world superpower. We were exporting our culture to all over the world, all over the globe. And the thing that had really made us like that, the thing that made us win the war was our nuclear weaponry.
Right.
So it seemed really cool and shiny and mysterious.
And let's apply to superheroes.
Right. Well, I mean, it made us superpower. So maybe it can make people superpowered too.
Right.
And of course, I think Aaron, maybe you could comment on this. How that seems to have changed over time. If you look through the history of comic books, there's these brief spikes where it's like, oh yeah, just bathe in radiation and it's awesome, and it'll give you superpowers, and then it'll change to, maybe you end up in a wheelchair even though you're a telepath, or maybe you just get cancer and die.
Well, I mean, I think when you're talking about superheroes who gain their power from radiation, that is more of a trope through a concentrated period, but it happens to be a concentrated period in which a lot of these popular characters that are then reused again and again come from. I'm not actually sure offhand if there's a whole lot in American superhero comics focusing on radiation just being completely a destructive thing to the human body.
Dr. Manhattan, Watchmen.
Oh, yeah.
Right?
Yeah.
That's a good one.
Yeah, that's a great example.
And that's where he gets blasted apart in a Dr. Manhattan gets blasted apart in some kind of nuclear testing chamber, and then reassembles himself with superpowers that isn't really explained. But then, of course, later in the comics, spoiler alert, or in the movie, if you've seen Zack Snyder's version, basically he gets made unstable because everyone's like, oh wait, you're giving everyone cancer because you blow glue, you blow blue. And then he goes to Mars. Yeah.
So one other thing I wanted to talk about. This is more of a historical story, more in the DC Marvel universes. A lot of scientists are the ones that are becoming these superheroes. We have Reed Richards, who is a doctor. Actually, I think if I'm not mistaken, some of the early stories in the comics are that he revered Einstein. I think in one of the later adaptations of the Fantastic Four, Reed Richards actually has a dog named Einstein, if I'm not mistaken. The comic book family could tell me if I'm correct or not. We have him, Dr. Bruce Banner. We have, even I would even put Tony Stark in that equation because he was an engineer. He was, involved in, the creation of machinery and whatnot. Why is that? I mean, I know that you're more into like the comic book history and you know the I guess the historical trajectory of this. Is there like a reason why perhaps the writers decided to go down that route?
Well, I mean, I'd say it's very convenient because it allows your character to. Oftentimes, the kind of scientists that are these superhero characters are particularly focused in a kind of engineering field, so they're able to make all sorts of devices for themselves. Even Spider-Man, makes his own web shooter.
Yep.
He's just, he's
Super
got that
genius.
basis from his high school.
Right.
There definitely is a historical precedent to it in terms of science fiction and stuff like that. We already mentioned Doc Savage, who was just great at everything,
Yeah.
including being a brilliant scientist. There was the boy genius, Tom Swift, was a very early one, the early 19th century, and he just continued on as a character. I'd say that's pretty much the primary reason is that, it allows your character to have sort of an extra superpower in their abilities to both create devices for themselves, or sometimes I think it can get a little more esoteric.
Yeah, definitely.
Yeah, I think that's right, though. I think Aaron's onto something. The idea that it's just a very convenient storytelling device where you can always have you can have your character kind of MacGyver his or her way out of any situation through the power of thought, the pure power of thought. It kind of makes me think that in some ways we could say that Einstein has certainly influenced or shaped superpowers in various superheroes through his own superpower, right? His own superpower of not only just being a very careful observer, being very good at math, despite what he said. He was great at math, and being a good scientist. He was able to visualize things realistically in a very good way, and then act on those visualizations, these thought experiments, the Gedanken experiments he called them, to come to novel hypotheses that turned out to be true. So it's really a remarkable thing. And then folks, obviously, everyone talks about the next Einstein. When will we find the next Einstein? I don't know the answer to that question, but when and if they do come around, if there ever will be another individual like that, another Einstein, another Newton, it will be because of their similar ability to kind of synthesize ideas, use their intuition to visualize, a new way of seeing things.
Right, exactly. I wanted to, we're going to take some questions in a few minutes, just two more points before we wrap up. I saw that we have, you're the unknown, or the indie comic genius here. We're more the mainstream guys. But
dilettante would be a good term.
But we have an edition of E-Man on display here, and E-Man has been one of the comics that I think really has come to embrace the principles of Einstein. So, what do you? I know that you've had a chance to read some of the E-Man issues. Do you think that it accurately tips the hat to Einstein when it comes to celebrating his science, his scientific theories, or is it just a bunch of gobbledygook?
Well, I mean, like most science as depicted in superhero comics, it would lean towards gobbledygook. Basically, E-Man was a character who was basically in the mode of Plastic Man. If you're familiar with him, as very sort of humorous character who can basically turn into anything. And I believe the idea with E-Man is that because energy and mass are equivalent, his mass is able to just turn into energy and be able to thus turn into any form of mass that he wants.
Right.
That is pretty useful.
Yeah, exactly. Last question. If Einstein had a superhero power, or maybe he did have a superhero power, what would it be?
So besides like basically being super intelligent, which he kind of seems to have been, and then his remarkable ability to visualize and have I think this kind of comes down to the classic divide between flight and invisibility, right? And then there's other gradations, but it's one of these things where do you want to be someone who's kind of more surreptitious in your behavior, and you want to be observing stealthily and just kind of knowing secrets, or are you more about being like, look at me, I can fly, this is awesome? Like, I don't know. I feel like he would be more on the invisible side, not so much because he wanted to be invisible, but because he wants to see the invisible.
Right.
He wants to see the invisible world. He
Exactly.
wants to understand it.
Exactly.
So I hate to speak for Einstein, but I would kind of say something like that. Or maybe he'd be more like Doctor Strange.
Yeah, I think that he definitely has that
opening portals to new worlds.
Yeah, exactly.
I'd say he'd have a super strong tongue based on the one photo that always gets.
Actually, it looks like stretching powers almost like Reed Richards-esque. It is quite long with the tongue. But
Yeah, for sure. Let's take some questions. So one question that we actually have is, actually more speaking to the general theme of our conversation, do you think the writers of these comic books were thinking about Einstein when they conceived some of these characters? Or in general, maybe not specifically Einstein, but perhaps the laws of physics or the laws of science?
I think that whenever, especially in the immediate post-war era, I think almost whenever a scientist is depicted, they do tend to follow a lot of the tropes that maybe were set up or inspired by Einstein. So they tend to have wild gray hair, often speak in a German or somewhat Bavarian accent. Usually man, often facial hair, quiet, understudied. Maybe they play the violin or go sailing every now and then. Wear, shoes that aren't very sensible. These are all things Einstein did. So I think that you can see the inspiration there. And then I think there's other examples that you were mentioning in one of our conversations that. Abraham Erskine, what was the story there?
Oh, yeah. So this is actually a pretty cool story. So I don't know if there's any confirmation. If anybody from Marvel is actually watching this, let me know. So there's a story that Abraham Erskine, who is the doctor that creates Steve Rogers into Captain America, was named after Albert Einstein. So the idea that, his initials were AE, Albert Einstein, also Dr. Erskine was German. And he had a bit of like the frizzy look. And actually, if you watch Captain America, the First Avenger, Stanley Tucci's depiction of Abraham Erskine is not exactly the way Einstein looks, but it has like that, scientist, ruffled type of look to him. And it's quite unique, if you will. It's something that we definitely are not accustomed to seeing, as a depiction of Einstein. But I guess that could be like a bit of a hat tip to him. Sort of based on that question that we got on Facebook as a follow-up to that, I know that while we were prepping for this, I showed you guys all the cameos of Einstein here. I guess that is even another question. Why would they feature Einstein? Why wouldn't they feature, let's say, a Carl Sagan or even an Isaac Newton, even though he's from a different century, but, and these were, in terms of time, these are based in the 50s and 60s and, or even the 40s, if you will. So what could be the, what's the rationale? Was it because Einstein had that much of a celebrity status at that time, or were his scientific theories that widely disseminated that the writers perhaps did want to embed that in the comic book strips?
Yeah, I think that's more to do with just his cultural fluency, the way that everyone pretty much knew and recognized him. And not that all of his stuff is easy to explain, but especially the linkage between things like nuclear power and nuclear weaponry, which he did not directly develop, obviously, but which was often used, E equals MC squared was often used, as I just did earlier, to explain the power of nuclear weapons and nuclear power. I think that linkage is pretty clear and visceral, versus something where it's like, well, if you just mix up these chemicals here in this test tube and get some micropipettes, and people are like, wait, what? You lost me, pencil neck, I'm done. I'm going to read my comic. So I think that making big explosions or black holes, stuff like that, is all pretty sexy and very easy to intuit and very, very compelling for the comic book form.
Yep. There was a question from Jean-Guy Levoy. I'm butchering my French, I'm sorry. He asked if there were any quotes from Einstein regarding superheroes. I wish there was. How cool would that have been? I mean, I could only imagine what he would say about Superman. Although, actually, here's a fun fact that I just came across. So, in 1940, if I'm not mistaken, it was Batman. So Batman was featured as like a cameo in 1939 in the early Detective Comics, and then Batman had his own, because of his prominence in DC's early days. DC decided to create Batman's own comic book. And the significance of that date actually is that's the same year that Einstein became a U.S. citizen. So, it's not an actual causal connection, if you will, but it just goes to show you how Even in some prominent years, Einstein still had some status, and obviously Einstein's citizenship to the U.S. was a really big event, and perhaps that was the kickstart to Einstein's feature in comic books.
Yeah, I could see that. And the thing about Einstein's quotes, you have to be really careful. What was his name again?
Jean Guy.
Jean Guy. You have to be really careful with Einstein's quotes on the internet because I think actually there's a quote from Einstein. You can find it on the internet that says 70% of the quotes about me that I said on the internet are wrong. That you can look it up on the internet; it's there.
It's all there.
So really, I mean, just saying, there's a lot of things that people say he said that there's very little evidence that he said. I mean, but I would not be surprised at all if he had a favorite comic book character, just like we do.
Who do you think it would be? I mean, part of me feels like it would be Doctor Strange because of that notion of traveling into different alternate dimensions and portals and wormholes, if you will. And even Doctor Strange had a little bit of that ability to fly and suspend himself. Actually, his coat, his robe is, if I'm not mistaken, the science of it is that it can levitate on its own. So there's even that notion; it could defy the laws of gravity. But I will say, maybe from a more macro perspective, not necessarily from a more specific comic book superhero perspective, I think he would really like Jack Kirby's style of animation. I think there's something about Jack Kirby that I think he would like that really animates science really well. I think he would also enjoy some Ditko. I think I think Ditko's a bit unique, but I leave it to you guys to think if that's accurate or not.
Yeah, well, I guess are we limiting ourselves to his life because he died? Let's see, was it the early or mid 50s? So that's like Silver Age, right? Is that kind of early Silver Age? Or is that still Golden Age? Yeah. So I'm kind of wondering what franchises he was even exposed to, or maybe what he might have read in between pondering a unified theory of everything for the universe. I see him being more of a Marvel guy.
Yeah, I think so.
Yeah.
Although, funny enough, DC has featured Einstein way more than Marvel has. Marvel has only, actually, I think Captain America and Marvel team up with Vision and Spider-Man are the only two times in Marvel's history that Einstein has been featured, and he was actually featured as an android, not even as the real thing. Whereas,
get it together, Marvel.
Come on, Marvel.
Come on.
It shouldn't have been Abraham Erskine. It should have been Albert Einstein making Steve Rogers into Captain America.
Well, I mean, as a I guess half jokingly, I mean, maybe the representative of the estate of Albert Einstein, maybe we need to reach out and figure out how. Marvel, we're here to help.
Marvel, call us.
Yeah.
I'm pretty sure that superhero deconstructions, which were all the rage in the 90s, would involve Einstein and Oppenheimer and all sorts of fellows in that vein. Personally, I think Einstein would probably be like Picasso and prefer the Katzenjammer kids.
Yeah, you never know. One question that we have here. Now that we have the discovery of gravitational waves confirmed, could we see that element embedded in superhero comic books in the future? Which is really interesting because that's a prediction that Einstein made 100 years ago this year, and it in some way it deals with the merger of black holes. So could it be the conception? Could a comic book writer create a super wormhole where it could go to something even beyond time travel?
Well, of course, and I think that we will probably see some plot lines and devices and things that will spring from the forefronts of science as we always do. I get pretty tickled thinking about imagery in particular that's coming in from places like Rosetta at the comet that it's about to crash land into this weekend, or New Horizons when it passed by Pluto. This is a little different than the reason why I'm going here is because it's hard to imagine how you're going to visualize, I guess, the gravitational waves and things like that. I'm thinking about comic books as a visual medium. I guess you could do Kirby-esque stipples and stuff.
Yeah, the thing of going abstract has been a popular move.
So you could do that. So I shouldn't place constraints on their creativity, the artist's creativity. But always I think artists and writers, people who are kind of the Imagineers here are drawing inspiration from real life events. And for me, I'm really excited to see what they're going to do with the imagery that we're getting back from interplanetary probes. I can imagine Hollywood movies and comic strips that are going to have lots of places that all of a sudden look like the icy landscapes of Pluto in the next couple of years.
Yeah, you never know. Well, we're just winding down in time. Just as a quick heads up, this will live on Facebook for forever.
Oh!
So you can definitely tune in to this conversation. Also, we have our friends at Scientific American creating a more high-res version of this video, so you can check that out. Once that video goes live, we'll definitely be able to share it. We're just a heads up, if you want to tune into Scientific American, you can check them out at is it scientificamerican.org or SciAm.org? .com. SciAm.com. And you can check them out and learn just a little bit more about what they're doing. You can read some of Lee's work and Aaron's work there. Also, just a quick heads up, we were wearing these T-shirts. Let's model it real quick, gentlemen. We were wearing these T-shirts, and we actually have a third T-shirt that's not in camera here. But you can buy these now. They're available on the Einstein Gear Launch website. You can go to http://bit.ly/Einstein Comic Store, if I'm not mistaken. Let me double check real quick. Yes, sorry. http://bit.ly/Einstein Comic Shop. At the end of this chat, I'm going to put a comment so that you guys can check it out. We'll also put a dedicated post, and we'll take a picture to model these T-shirts because they're quite comfortable, they're very nice, and they're very superhero-esque, and they honor Einstein in a really awesome way. I want to thank Aaron Shutak for your time. Lee, thank you so much for your time.
Yes.
It was so much fun talking about Einstein and comic books. Thank you all so much for tuning in. And if you want to check out some of these comic books, we've shared this in the past on the Einstein social media pages. We've shared some snippets of it, but we'll definitely let you know if you're interested in learning more about an issue or two. Anyway, thank you all so much for tuning in, and we'll see you again in the next Einstein Facebook Live.